Hey there, Mr. Sutton here, bringing you the Algebra 2 Honors 5-7 Part 2 homework solutions on inverse functions. For this problem, we're going to be sketching an inverse of the function represented in the graph. So first, let's pick out a few easy points. So one point is this 0, negative 3 here, and another one right here, roughly-ish. I mean, it's not maybe exact, but it's close enough. 2, 2-ish. Again, this is just a sketch. So next, let's do the line y equals x that we can use to reflect things here. And going back and reflecting these points, we've got, let's see, this is going over here. This one is going in roughly the same place. It's basically on the line of reflection. And then we just draw a line through those. And this gives us our inverse function. To draw the inverse function for this graph, let's put in a few points that we can reflect later on. So I've got a point, let's see. It's not ideal, it's not a great grid line, but I'm going to use this point right here. And then let me do another point right up here. And this turnaround spot's another good one, another good point right here. And we can do like the end up here as well. You kind of want 5 points when you're doing one of these cubic shaped sort of deals. So let's do y equals x now, and then start reflecting these. So this one I can reflect to roughly over here. This one I can reflect down to, I guess this is 1, negative 1 here. This one gets reflected over to 2, 0. And then we've got 1, 3 getting reflected to 3, 1. I'm just switching the x and y's. And then this one will go over to right here. All right, let's graph a line through those, graph a curve through those, and there's our inverse. To determine whether these are inverse functions and do it rigorously, we have to plug each function into the other function and make sure that we get x both times. So let's start with f of g of x. So that's going to be f of 5x plus 1. So that's going to be 5x plus 1 minus 1 over 5. If we do that, these 1's are canceling, leaving us with just 5x over 5, which comes out to x. So this is good, but we have to go the other way as well. G of f of x. So that's g of x minus 1 over 5. So we have 5 times x minus 1 over 5 plus 1. These 5's are going to cancel, leaving us with x minus 1 and then a plus 1. 1's also cancel, leaving us with x. Since we got x both ways, that means that f and g are inverses. To see if this f and g function are inverses, we have to plug each one into the other one and see if we get x each time. So let's do f of g first. That's going to be f of x over 2 plus 9. So that's going to be 2 times all that stuff minus 9. Distributing this 2, the 2's cancel, leaving us with an x here. And then 2 times 9 is 18, and we still have that minus 9 over there. 18 minus 9 is 9, so we have x plus 9. And x plus 9 does not equal x. So that right away proves that these are not inverses. On this one, we are told that the speed of sound in meters per second through air is approximated by this f of x function, and x apparently is the temperature in Celsius. So this is kind of interesting. I mean, just thinking about the real life part of this, the way this is structured, the higher your temperature is, the faster sound is traveling through the air. But it's not a one-to-one relationship, it's a square root, so this is actually a speed that's growing very slowly, even with huge increases in temperature. Anyway, let's go and actually answer the question. They want us to find and interpret f inverse of 340. So to get the inverse function, we're going to start by replacing y with x and x with y, basically switching those. So we've got x equals 20 radical y plus 273. And now we're going to solve for y. So to start that, we'll divide by 20. So we have x over 20. Then we have to square both sides. So x over 20 squared equals y plus 273. And at last, we've got to subtract 273 as well. So we have f inverse equals x over 2 quantity squared minus 273. So there's one other thing I'm going to add to this, by the way. Because my original function has this square root, that means we have this range that at the very least is, non-negative, right? We can't get negative values back from this square root function. We can only get 0 or higher. So because the original range is non-negative, that means that the inverse domain, which is essentially the original range, has to also be non-negative. So we have to stipulate that x is greater than or equal to 0 for this to be a true function. Anyway, let's go ahead and plug 340 into all this. So we have 340 over 2 squared minus 273. And let me think here. Could I do this without a calculator? I probably could, but just to be on the safe side, let's use the calculator. So to really make sure I get this right, I'm going to write my inverse function out, and then I'll just plug something into it. So we have a parentheses, fraction, x over 20, close parentheses, square that, and then minus 273. And I don't really need to write my, my domain restriction over here. I'll just make sure I don't plug in negative numbers. So down here we've got g of, and we're going to plug in 340 for that, and that comes out to 16. All right, so what does that actually mean? Well, the original function took, let's see here, x was temperature in the original function, and the output for that was speed. That means that the input for the inverse is speed, and the output is temperature. So we're saying at a speed of 340 meters per second, that is given to us by an air temperature that is 16 degrees Celsius. And I should say meters per second there. There we go, meters per second. Slightly different than miles per hour.